Welcome to this engineering mechanics tutorial. Today, we'll analyze a truss using the method of sections to determine the forces in members A, B, and BC. Let's start by drawing our truss. Here we have a simple truss with members arranged in a triangular pattern. The truss is supported by a pin at A and a roller at D. A vertical load of 20 kips acts downward at point C. The method of sections involves making an imaginary cut through the truss to expose the internal forces in the members we want to analyze. In this case, we'll make our cut through members A, B, and BC. Let's isolate the left portion of the truss and draw its free body diagram. The internal forces in our members will act along their respective lines of action. To solve for the member forces, we'll use the equations of equilibrium. The sum of forces in both x and y directions must equal 0, and the sum of moments about any point must equal 0. After solving these equations, we find that member B has a force of 27.5 kips in compression, member AE has a force of 25 kips in tension, and member BC has a force of 15 kips in compression. The method of sections is a powerful tool for analyzing trusses, especially when we want to find forces in multiple members that can be cut by a single section.